Okay, good morning to everyone. I'm very glad to have this opportunity to share with you the sustainable water management in Singapore. Okay, I'm Professor Jiangyong from the Center for Water Research, National University of Singapore. Okay, and I also been in charge of the environment engineering program, as well as I'm also in charge of the environmental engineering, hydraulics and hydrology and climate change section in my Department of Civil and Environmental Engineering. So it is a very nice opportunity, golden opportunity to be invited here to share with the audience some experiences and also the knowledges we gain in terms of water management in Singapore. Okay, so I'm going to actually start by giving you some general background of the Singapore. Okay, for a lot of you, maybe you haven't gotten the chance to travel to this part of the world. Singapore is a city-state, and as you can see that the land area is only 721 kilometers square, and population in Singapore is 5.8 million, and the average rainfall per year, okay, this value is quite high, 2.3 meter, right? So this actually gives us a lot of precipitation from the sky, but we do have our side of the challenges. Okay, the average water demand, it's 430 milligallon per day, and 45% of the water it's used for domestic supply, and another 55% of the water is for industrial sectors. So this actually gives you some information about Singapore, okay, area population, and especially rainfall as well as the water supply. Okay, so Singapore actually is a city-state, as I mentioned, located in a tropical region, and it is a water scarce country, okay? And you may wonder why we have so much precipitation, right? Singapore count on the rain as a nature source of the water, right? We have plenty of the rain, that's true, but we are very constrained by our land area, which limits our storage space of the water. Okay, so that's why the Water Resource Institute in the world actually ranks Singapore as the country with high, the water stress, and we recognize that. All right, we recognize this is our challenge. This is a problem we are facing. So Singapore in the past 20, 30 years, try to try different ways, try putting a lot of efforts to make Singapore's water sustainable. So in here, that's why I got something to share with you people, what we have done to make so-called sustainable water management in Singapore. Okay, so first strategy is through the infrastructure building, right? So in Singapore, in the past, we usually, make use of the protected catchment, right, to actually supply our water, for domestic, for industry users. But, nowadays, because of the, more and more demand for water, so, and also because of the, available of the technology, we are able to think about non-protected catchment as well as the urbanized catchment. So in terms of the, Singapore's catchment for the water, right, we are actually trying to expand, okay, along the years, right, making use of the technologies, okay, that help us to do so, right? Give you some examples. For example, Marina Reservoir, it's a relatively new reservoir. It's the first reservoir in the city center, which collects rainwater from the highly urbanized catchment. And this was built in 2010. Okay, 1 year later, we have another two smaller reservoirs. One is called Punggol Reservoir, another is Serangoon Reservoir. Okay, and they, together with Marina Reservoir, they increase Singapore's catchment area from the previous probably only half of the land area now become 2/3 of the land area. So this is something we have done through the infrastructure building to expand the catchment. And on top of that, right, there's also a reservoir integration scheme, which was completed in 2007. So what we do under this reservoir integrated scheme, okay, we collect the various reservoirs, okay, through a system of the pumps and pipeline. So excess water from one reservoir is able to be pumped to another reservoir for storage. So in the way that, you know, we are able to actually manage the quantity of the water and quality of the water, optimize the performance of the reservoir. And you can see that through this integration scheme, reservoir water yield can be increased without actually building for additional reservoirs. So this is something we have done nicely, you know, even on top of like building those you know, novel reservoirs, which is located in the city center. Okay, another strategy we have is so-called harvesting unconventional water resources. So Singapore come up with an integrated water management system, okay? And underneath this integrated water management system, we have 4 national types. Singapore developed 4 national types, okay, to ensure a stable and sustainable supply of water. Okay, these 4 national types consist of, number 1, water from our local catchment. All right, so basically water we obtained from our those reservoirs. Number 2, imported water from the neighboring country. Okay, number 3 and number 4, those are the 2 national taps recently we developed, and that's why I like to highlight more to you. Okay, number 3 is called new water, a highly purified reclaimed water. Number 4 is desalinated water. Okay, so Singapore's in the past 20 years, 2 decades, we put in a lot of effort to develop number 3 and number 4 national types. For new water, which is our 3rd national type. Okay, so new water basically is treated effluent from the, we call it water reclamation plant, right? And it goes through processes like a microfiltration and reverse osmosis, okay, and also the ultraviolet disinfection. So eventually we generate very high quality reclaimed water. We name it as new water, okay? So new water, in terms of the current status, new water is able to meet up to 40% of the national's current water need. Okay, and then you know, almost like 40 years later, we expected that new water is going to be able to provide 55% of the Singapore's future water demand. Okay, so you can see this is one of the new water factory at east part of Singapore, very close to our airport. And this is a reverse osmosis technology we make use, right? Which is a core technology actually help us to make the new water become a reality. Okay, so before we actually launch the new water project, okay, we actually studied the new water quality very intensively. All right, so what we have done, we look into a number of the water quality parameters from the physical, chemical, microbiological parameters. And eventually we draw a conclusion that new water is able to even surpass the existing water quality of the potable water we have. And another thing we have done is we adopt the animals, right, to study the health effect, the potential health effect. Eventually, we draw a conclusion that new water doesn't show any negative health impact, right, to those animal models we have chosen. So these 2 very important R&D technology, you know, kind of a research project was conducted by a group of the researchers in National University of Singapore, right, before we actually make new water a reality for the society. So what we have done, okay, for this toxicity and carcinogenicity, you know, assessment, we make use of the mice as our model. So you can see this is our animal model, right? We feed them the concentrate we obtained from our new water and observe any potential toxicity and the carcinogenicity for the lifespan of the mice. And our conclusion is no negative health impact observed. And on top of that, we also study estrogenicity, right? We make use of the transgenic fish, which is also a very nice model. In fact, NUS is the one actually developed the protocol for the reclaimed water fish study, right? We are the first one in the whole world actually developed such protocol. We developed during that period of time when we are studying the potential health impact of the new water. So we make use of this Japanese Medaka fish, and we observed 2 generations of the fish, and conclusion is that we couldn't observe the estrogenicity, right? Which means we didn't see any negative health impact from this new water. All right, so that's our third national tab. The fourth national tab, okay, it comes from desalination. So basically, the seawater goes through the reverse osmosis technology, and you will generate the drinking water, and you will actually goes into our drinking water distribution network and blend with our current drinking water. So, what is the status for our desalination? In terms of providing the water supply to Singapore, right? 2005, okay, we developed the first desalination plant in Singapore, and that is one of the largest seawater desalination plant in the region. Okay, and subsequently we have even larger desalination plant developed, and then 2017 we got a third desalination plant. 2020 we got a fourth desalination plant. Okay, so the aim is that by 2060, right, we hope that we are able to make desalinated water to provide us 30% of the Singapore's future water demand. Okay, so after we have developed such integrated water management system, right, we are able to actually put the water in a closed loop. You are able to see that the water come out, the water come from the sky, it precipitated to the ground. Okay, it will be captured by our reservoir, treated for domestic and industry use, and the used water will be treated by the wastewater treatment plant, and some of them will go to our new water factory, and it will be actually come back to serve our industry, and small portion will goes into our reservoir to recharge our reservoir. Okay, seawater will be desalinated, and it will provide drinking water, and directly goes into our domestic use as well as industry use. So from here, you have a very clear idea what do I mean the integrated water system in Singapore, and it consists of 4 national types, and you make our water supply become sustainable, become sufficient, right? We actually are able to overcome the challenges which originally we faced. So now, okay, I would like to actually add a little bit more, okay, on top of just now the 2 strategies, because the challenges we face also give us opportunity, right? And give us especially opportunity to develop industry, water industry. Water industry very much like to promote innovation in terms of technology, in terms of commercialization of those novel technologies. And of course, Singapore also very much want to develop industry in that direction. And through developing our industry, we are able to actually make Singapore's water management even more sustainable. So R&D and technology transfer and the commercialization is very important aspect. Okay, I'd like to highlight to you that since I'm heading this Center for Water Research as a director, I'd like to highlight to you that the Center for Water Research was developed to actually, very closely collaborate with industry to provide R&D, capabilities and water solutions to the industry. At the meantime, we also generate a lot of manpower, capable manpower, to support the water industry. So Center for Water Research work on 4 aspects of the research and development domain. Okay, one of them is used water treatment and reuse, right? Another is advanced membrane process. Third one is water treatment and water quality assessment. And last one is about renewable energy. Okay, so I go through briefly each of the aspects, what we do. Okay, in terms of used water treatment and reuse, we focus on water quality enhancement and reuse using technologies like biological process, anaerobic, aerobic, right? Cyclic biofilm systems, right? We look at the performance, reactor design, operational protocols, and so on and so forth. Give you one example, what we do recently, okay, we have a technology which couples advanced oxidation process together with biological process, right, to treat industrial wastewater and try to achieve no COD concentration in the treated effluent for two purposes. One is to meet the discharge standard we want to discharge, or if the quality is acceptable to the plant also can recycle this water for their own reuse purposes. So in the Center for Water Research, and we develop advanced oxidation process like ozonation system and Fenton system, right? They couple with downstream biological process. It can be USB followed by NBR. It can be just simply followed by a BAC system, which is a biologically active carbon. So we can make the water reusable, or we can make the water meet the discharge standard, even very stringent discharge standard. This kind of combination is capable of doing that. So we have filed a patent. The patent is mainly focusing on the catalytic ozonation process. And we also build a pilot scale system, which is hosted in this container. And we move this pilot scale system to our one of the industrial island, okay, to prove this technology is able to work in the real situation for two types of the industrial wastewater. One is reverse osmosis concentrate, another is a phenolic wastewater. Okay, so after we finish this round of the pilot testing, this technology is ready to go for commercialization. So this is one example I'd like to highlight. Under that, used water treatment and reuse. The second domain we work on is advanced membrane process. Okay, and then we cover a different type of membrane process, MFUF, RO, forward osmosis. We work on the understanding fundamental mechanisms and pollutants transport series, process optimization, as well as a innovative membrane system development. Okay, one of the examples I like to highlight to you is that in this Center for Water Research, we emphasize a lot on the next generation process for water reclamation, especially for our new water. So we put MBR system ahead of the RO process. So some of the RO brine actually can go back to the MBR, right, to form a very compact system. We call it integrated membrane biological reactor. Okay, this compact system is able to offer us minimize the residual contaminants. It's able to offer us even better quality of the product water, right, coming out from this RO process. But of course, we have the challenges where, for example, recalcitrant organic matters in the MBR can be a challenge. Elevated TDS level can be a challenge. Membrane fouling in the MBR is another challenge. So, okay, this kind of technology is something we are very interested to develop, and we want to actually further make it to be applicable for the next generation of the water reclamation. Third domain is about water treatment and the water quality assessment. Okay, so in this particular domain, we look at how to optimize various disinfection technologies, advanced oxidation processes, membrane and absorption technologies, okay, to produce water with chemical and microbiological safety, right? So we have a novel treatment system developed, optimized for emerging organic contaminants as well as parthenogenic microorganisms control in water. Right, and one of the examples I like to highlight to you is this bioretention system, novel bioretention system we developed for stormwater management. Okay, and we have gone through a number of the laboratory scale testing, pilot scale, planter box testing. We even actually demonstrate in the field. Right, we build the full-scale bioretention system in the field to demonstrate its capability to enhance the stormwater quality, to treat, for example, those pollutants including solids, nitrogen, phosphorus, microorganisms, heavy metals. And this technology, of course, has been filed a patent in Singapore, and we are currently actually employing this technology to another climate, which is at the Tianjin, China, Tianjin Eco City, China, to demonstrate that this technology is able to work in a different climate, in the different soil conditions with different plants species, and handle different pollution scenarios. So this is something actually we are very actively working on it now. Okay, the last domain the Center for Water Research is currently working on, we look at renewable energy and resources. Okay, we developed a innovative energy resources harnessing technology from the used water. For example, we look into microbial fuel cell. We look into the biodiesel generation from the algae, which can grow in the used water. And we also try to recover useful products from the used water. Okay, one example I'd like to mention to you is a project we have completed, which is called Cleaner and Greener Way to Treat Domestic Wastewater. So in this particular project, we have integrated anaerobic system as well as aerobic system. So we have UASB, anaerobic filter, and anaerobic SBR coupled with the downstream aerobic system, for example, NBR system, right? So in this case, actually, we try to make use of this combination, produce good quality of the reclaimed water, and we also minimize energy consumption in this combined system, right? And this kind of a combination is especially useful for tropical countries because of the temperature is very favorable for anaerobic system to be ahead of aerobic system. In a way, actually, we save a lot of energy for treating the domestic wastewater. At the meantime, we are able to ensure the good quality of the water coming out from this treatment system. So toward the end, I would like to highlight that the Center for Water Research emphasizes a lot on the partnership between industry, R&D institution, as well as education unit. So we work hand in hand to provide manpower, provide know-how, provide innovative technologies to water industry, so that actually it also serve its purpose to contribute to this Singapore's sustainable water management as a whole. So toward the end, I'd like to thank you very much for your attention to my talk. And if you want to find out more information about Center for Water Research, this is a website I'd like to mention to you. And you also can feel free to drop me an email if you have any questions, opinions. And if you like to explore any further discussions, I definitely like to welcome. Okay, with that, I would like to stop my presentation. Thank you very much. I hope to see you in the near future.